everybody. Welcome back to Sidewalk STEM. I'm Dr. B here this week. I've got some very special friends and helpers who I'll let introduce themselves. Some wonderful colleagues here at the East Lansing Public Library.
I'm Jillian. I'm the Youth Services Librarian here at East Lansing Public Library.
I'm Rihanna. I am the Teen Services Specialist here at the East Lansing Public Library.
Yeah. And so just recently, Jillian, you made some gingerbread houses.
Yeah, we had a lovely
with some
time.
young creators. I would call them sugar architects. These houses were so phenomenal and adorable and wonderful.
Yeah.
Some really cool designs.
You can see more of them on our social media. We've got some great stuff posted. This is just one sample of excellent work.
Absolutely. And a lot of marshmallows were used in the service of these architectural wonders. And I think marshmallows are pretty interesting for something I've been trying to put together for a long time, somewhat unsuccessfully, a functioning vacuum chamber. So I went out and I found one. Here's a simple model of a vacuum chamber. And what this is it's a compartment. And when we seal it up, there's a rubber ring down here that'll form a fairly airtight seal. We'll take this little stopper and we'll put it in this side of the chamber. And then we've got this syringe that when pulled out and pushed in is going to remove air from inside the chamber, pull it through the syringe, and then force the excess out this way. So what we're going to do is increasingly remove air from this little jar here until we get close to approximating the vacuum of space, where there's no air, there's no molecules bouncing around, basically just emptiness. And they're very hard to create. Nature abhors a vacuum. Those little molecules always try and get back in there and fill it back up as fast as they can, and this kind of contraption makes that a little bit harder. So what we'll do is we'll start by taking a regular little squishy old marshmallow from our gingerbread creations, and then we'll push this on. And Ree, if you want to hold that down and kind of press it against the ring, that makes it an airtight seal.
Open that, yeah?
Yeah.
Okay.
Jillian's going to pull the syringe, and each pump of that syringe is going to bring air out. And if we watch the marshmallow, we can see it start to change. So you can see with each pull, it starts to swell up a bit. It looks like it's growing in there, and then pumps back down, and then pulls it back out.
And it's making the syringe harder to pull, too.
Yeah. The less air that remains in that jar, the harder and harder it gets to draw anything out of there with the syringe. And so that marshmallow has swelled up a fair amount. Here's kind of a regular size one next to it for comparison.
Yeah.
And then, Rhea, if you want to grab that little stopper and just kind of pull it out the front, we'll watch what happens to the marshmallow. Ah, so it gets kind of squished back down and shrinks up.
It's still squishy, but wow, it kind of wrinkled it up.
Yeah.
Yeah, so what's happening there is these marshmallows are a very spongy kind of food. They've got a lot of air pockets and air inside of them. And as we're pulling the air out of that jar, the air pockets inside the marshmallows are able to start to expand because they're not getting pressed and squeezed by the air pressure that's all around the room. So the room in here and everywhere on Earth has air pressure, air molecules bouncing all around and pushing on things. And we've seen in some sidewalk stems how powerful that force of air pressure can be. Once we take that away, the air inside here starts to expand.
That's pretty cool.
So let's try
Let's see
something
what would
else.
happen with something else.
Yeah, well, let's find out. So we've got some of these balloons, and these are really small balloons. And, whoa, I mean, that's about as much as I can blow this thing up with my lungs. That is some really strong material there. It doesn't want to expand much more than this. So we've got air inside this balloon. We're going to tuck it in there. And if you want to hold on to that, we'll do the same thing. We'll make sure our stopper's in. Is our stopper back in there?
It's back in there.
Perfect. So we've got our seal. Now we're going to start to pull this out. And okay, the vacuum in there is already making that balloon swell up so much, more than my lungs could have. I blew that thing up as much as I possibly could. And you can see it's completely filled the bottom of the jar. And I can't even steal any more air out of there because it's going down and blocking this valve here. But we have gotten it out of there. Now we pull this out, we'll see what happens when we let air back into the chamber. Squishes that balloon back down to the shape it wants to be, because it's already stretched out where it wants to be against normal pressure.
Yeah.
Neat. So
Cool.
what would happen if we put something that wasn't squishy in there?
That's a good question. Let's see what we've got. We've got an orange, not squishy. Not too much like a balloon of nature, but it's got an outer shell. It's got definitely some air and material in there.
Okay.
I have no idea what's going to happen with this. I'm pretty excited. Reed, do you want to pump this one?
Yeah, sure.
All right, we'll stick that stopper back in. Don't if you want to hold it down.
All right.
I will hold this top.
I'm not sure what's going to happen here.
Oh, it's getting really hard.
Yeah, so it gets harder and harder as that air in the chamber is less and less. It's hard to pull against that vacuum. And our orange is holding up pretty well. So even though it's got some air pockets and gases inside of it, its material is pretty strong. It's not going to have much give it even in that vacuum of our pseudo outer space right here.
Yeah.
Let's just see what happens if we pull this back out. Oh, it definitely shrunk a little bit. So it did do some expansion, just slow and steady.
It's not like wrinkled or squishy the way the other things are, but interesting.
Yeah, kind of back to its normal shape. Yeah, the marshmallows get a little bit harder.
Resilient.
Kind of changed afterwards and they get crushed by that air coming back in.
Oh.
This is just a little jar of regular old tap water.
Okay, where's our little valve?
A little stopper valve that I stole is back here. We'll seal this up, and this stopper valve is really important because that keeps the air that's in the chamber separate from the room, so then we can just steal what's in the chamber away.
Okay. Do you want to hold down? Okay.
All right, so let's watch that water and see if anything happens. Interesting.
Am I seeing bubbles?
I think you are seeing some little bubbles forming. Let's get as much of a vacuum in there as we can. It's not easy work creating a vacuum. Who knew little tiny air molecules that we can just wave around with our hands and breathe in and out with our lungs are so hard to convince to leave a vacuum. There's a lot of bubbles forming inside there now.
I think that might be the most I can do.
Yeah, that might be. There might not be much air left in there to steal. Let's see, I'm going to try and steal a little more air.
Yeah, see if you can do some more.
More of a vacuum. Yeah, boy, there's not much. That is pretty much as close as this little chamber is going to allow us to get to a vacuum, which is probably not 0 atmospheres like space, but
still pretty impressive.
Yeah, and so what's happening is there's dissolved gases inside water and any liquid, and they're generally held in there. And then once you sort of reduce the pressure, the air pressure that's outside the liquid pushing that stuff down in, it can start to escape. And so if you ever try to cook in somewhere like Denver or a place with really high elevation, where the air is a little thinner, there's a little less air pressure, your water will actually boil at a lower temperature because it's easier to get those gases to start to escape. Boiling pressures are decreased.
Oh, that's why baking and cooking directions in higher elevations are different.
Exactly. Yeah. The wonders of science. I don't know if much is going to happen when we let the air back in there, but Jillian, if you want to pull that stopper.
Whoa.
Oh, that was pretty interesting. Still some bubbles on the edge, but it seemed like they might have shrank down a little bit as that pressure on the outside of the cup increased.
Interesting.
All right, well, I've got at least one more thing I'm super excited to test.
Oh, what's that?
This is an egg.
No!
I don't know what's going to happen. I've been really curious. I've resisted the temptation to look this up. There's theoretically gases inside this egg. Like the balloon or the marshmallow, it has an outer shell that's separating them from the air. But it might be kind of porous as well.
Is it a raw egg or a cooked egg?
It's a raw egg.
Oh boy.
Yeah, so if this goes like I kind of hope it does, but I don't know if the science will support that. We're going to find out.
Okay.
This is an experiment. We'll stick that chamber back on.
And then put a little plug in. All right.
All right, let's see what happens.
For science.
For science, this egg shall endure a bit of a vacuum.
Oh, yeah, this is going to be interesting. I can already tell. I think I see a crack beginning to form.
I'm really curious.
Now, I have seen videos. I'm not going to spoil it for anybody, though. But if you look at the back here, you can see there's a fissure.
Just a little one.
Just beginning.
And it might be that if it cracks at one weak spot, maybe some of the gases inside the egg are able to escape and standardize.
But it's a really small crack, so I don't know if it's actually going to burst or not.
All right, that's a pretty substantial vacuum. I think that's about as much as our chamber can get here.
It's still holding together.
Yeah.
Can see the crack a little bit more here on the back. There's a little bit of a fissure, but it also doesn't seem to be leaking anything. So it's a pretty sturdy egg.
Interesting. Well, let's find what happens if we let all that air rush back in. Oh, the egg held up. I wasn't sure what to expect. I think it's largely intact. So the egg was able to survive the pressures of the vacuum with the air pressure going back in. Awesome. Well, I've got a couple of more materials. Maybe we'll save those for your future site. Well, thank you very much to my special guest who do so many other wonderful things here at the library. And yeah, always fun to play with a vacuum chamber.
Oh, awesome.
Yeah.
We'll have to see what else we can put in there.
Absolutely. All right, well, thank you everyone for joining us, and we'll see you next time on another Sidewalks 10.